Okay guys, let's begin our discussion over the questions on polynomials. The first question for 1 mark says that give one example each of a binomial of degree 35 and of a monomial of degree 100. When it's talking about binomial, that means it has to have two terms, right? Both consisting of variable. And if the degree of that binomial expression has to be 35, that means the highest power of the variable has to be 35 such that that variable with the highest power 35 should have coefficient as non-zero. So, I can say binomial of degree 35 is x to the power 35. It has a non-zero coefficient 1. You can keep the coefficient as 2 also, 3 also, 4 also, 1 by 3 also, 7 by 9 also, minus 2 by 3 also. I am just keeping it simply to be 1. So, 1 into x to the power or 1 times x to the power 35 plus x to the power 34. That's it. This is your binomial expression. You can keep a minus here or a plus here, that's your choice. Again, coefficient of x to the power 34 can be any non-zero real number, that is your choice. I have kept it to be 1, you can keep it to be anything. But keep in mind that the degree of this variable should be less than 35. So that 35 happens to be the highest powers among all the powers in the expression. You can keep this degree to be 30 also, 2 also, 1 also, 33 also, 21 also, 27 also, keep it anything but strictly less than 35. Is it clear? So this is one of those expressions, and monomial of degree 100. Now this is very simple. This is a monomial of degree 100. You can keep it to be 2x to the power 100 also, any non-zero real number times x to the power 100. Only the coefficient has to be non-zero so that this doesn't vanish. Fine, I have kept it to be very simple, 1 times x to the power 100. Fine, in place of 1 you can keep any non-zero real number, that's your choice. Moving to the next one, verify whether the following are zeros of this polynomial indicated against it. So let's see. So they are suggesting us these two values, x equals minus 1 by root 3 and x equals 2 by root 3, and they are asking us whether these values are zeros of this polynomial px or not. Zeros of a polynomial px are those values of x which when you plug in the expression of px, the px expression becomes equal to 0. That means px vanishes for these values of x. Okay, that is the question asking. If my px vanishes for these values of x or any one of these values of x, that value is going to be said to be the 0 of px. So, px given to me is 3x square minus 1. In place of x, if I put minus 1 by root 3, let's see what I am getting. Minus 1 by root 3 whole square, this is minus 1. Just in place of x, I have put minus 1 by root 3. This is 3 into minus 1 square is 1, root 3 square is 3. 3 cancels out, you're left with 1 minus 1 which is 0. That means p of x when x is equal to minus 1 by root 3 is coming out to be 0. That means minus 1 by root 3 is definitely a 0 of px. But if I talk about 2 by root 3, in place of x if I put 2 by root 3, let's see what I am getting. 2 by root 3, the square minus 1. So 3 into 2 square is 4, root 3 square is 3 minus 1. 4 minus 1 is 3 which is not equal to 0. In place of x when you are putting 2 by root 3, you are getting p of x is coming equal to 3 but not equal to 0. That means px for x equals 2 by root 3 is not vanishing, but px for x equals minus 1 by root 3 is vanishing. So minus 1 by root 3 is a 0 of px but 2 by root 3 is not a 0 of px. So out of these two values, this is a 0, this is not a 0. It is also saying find the 0 of this polynomial. Now look at this polynomial, it is a linear polynomial. Degree is 1, right? Highest power of the variable is 1 with coefficient non-zero. So you have this to be a linear polynomial. How to find out the 0 of this polynomial? If you remember, whenever I have a linear polynomial like this is a general expression of a linear polynomial. What is that single unique value of x which is a 0 of this polynomial? A linear polynomial has a single unique 0. only one value of x is there, which is 0 of a linear polynomial. What is that value? Well, I want some value of x for which f of x is 0. That means some value of x which when I plug in the place of x, this expression becomes 0. That is what is the 0 of fx. That means I want such an x such that ax plus b is 0. That means I want such an x for which ax is equal to minus b. I want such an x such that x is equal to minus b by a. Already a is not equal to 0, so minus b by a is a real number. That single unique real number which can make this polynomial vanish is minus b by a. If you compare it with this expression, it looks like ax plus b, where a is 2 and b is 5. So for what value of x will 2x plus 5 be equal to 0? 2x plus 5 will be equal to 0 means 2x will be equal to minus 5 for x equals minus 5 by 2, that is minus b by a. So minus 5 by 2 is the unique sole single exactly 1 0 of 2x plus 5. Is it clear? In place of x, when you put minus 5 by 2, you will get 2x plus 5 equal to 0, and there is no other value of x which when you plug in the place of x in here, you can make it to be equal to 0. There is only one value which is minus 5 by 2. So only 1 0 it has, which is minus 5 by 2. Next question says that verify this identity. So let's try to verify. Well, if you try to look at this identity carefully, what is it reminding you of? We have done this identity, that is a plus b whole cube, a minus b whole cube. So if I talk about x minus y whole cube, it is x cube minus y cube minus 3xy x minus y. This is something that we are already well versed with. I want the expression for x cube minus y cube, so I will leave it as it is and bring everything on one side. So I will have x cube minus y cube equals x minus y whole cube plus 3xy x minus y. Now here there are 3x minus y's, here there is 1x minus y, so I will take out 1x minus y common. I will be left with x minus y whole square plus 3xy. Just try to multiply again. X minus y into x minus y whole square is x minus y whole cube, and x minus y into 3xy is 3xy x minus y. So again we are going to get back the same expression. Then you have x minus y. Open this up. What is x minus y whole square? It is x square plus y square minus twice of xy, and already you have thrice of xy. Plus 3xy minus 2xy is plus 1xy. So you get x minus y, x square plus y square plus xy. So you have got that x cube minus y cube is x minus y, x square plus y square plus xy, and that is what you had to verify. Next it is saying and factorize this expression 64m cube minus 343n cube. Can you recognize 64 is cube of which number? 4. 4 cube is 64 and 7 cube is 343. So 64 m cube minus 343n cube can be written as 4m whole cube minus 7n whole cube. Now it is looking like x cube minus y cube for x equals 4m and y equals 7n. And we have already developed this very expression that x cube minus y cube is x minus y, x square plus y square plus xy. Let's write it down. X minus y, x square plus y square plus xy. So this will become 4m minus 7n, 16m square plus 49n square plus 28mn. And this is the factorization of 64m cube minus 343n cube with the help of this identity. Cool? Next it says expand this using suitable identity and then factorize this expression. So one we have to expand, second we have to factorize. Okay? If you look at the expression carefully, what are you able to identify? It's of the form a plus b plus c whole square. Let's recall this identity. You all know x plus y plus z whole square is x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Here what you have? 3a, okay, minus 7b, let's write it as plus of minus 7b, minus c, let's write it as plus of minus c. Now you can treat 3a as x, minus 7b as y and minus c as z. You have exact same expression, x plus y plus z whole square. So what does this become? X square plus y square plus z square plus 2 into x into y plus 2 into y into z plus 2 into z into x. So this becomes 9a square plus 49b square plus c square, because minus c square is same as c square. This is minus 7 into 3 is 21, 21 into 2 is 42, so 42a into b. Here you have plus 14bc and here you have minus 6ac. Right? 3 into 2 is 6 minus 6ac, this becomes 7 into 2 14 plus 14bc and this is minus 42ab. This is the expansion of 3a minus 7b minus c whole square. Then it is saying to factorize this expression. Now please try to look at this expression carefully. You will be able to connect it to this expansion, x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Right? See, 4x square plus 9y square plus 16z square, this is going to resemble the same thing. 12xy, yz, zx. So somehow it is connecting us to this expansion. What is that x, what is that y, what is that z, such that x plus y plus z whole square is this expansion, is what we have to find out. So what do you have? You have 4x square plus 9y square plus 16z square plus 12xy minus 24yz, and then you have minus 16xz. Of course, I can write this as 2x whole square, this as 3y whole square, and this as 4z whole square. But can I say I can take this as my a, this as my b, this as my c, and write this entire expression as a plus b plus c whole square? No, I cannot. Because if I take a as 2x, b as 3y, c as 4z, then 2x plus 3y plus 4z whole square. In this expansion, of course, you will get 2x whole square, that is 4x square, plus 3y whole square, which is 9y square, plus 4z whole square, which is 16z square. After that, you want 2xy or 2ab. So 2 into 3x into 3y, that is 2 into 2, 4 into 3, 12xy, which you will get cool. After that, it will be 2yz plus 2yz. So 2 into 3y into 4z you will have. So 2 into 3y into 4z, which is going to give you 24yz, but with a plus sign. Here it is sitting with a minus sign. That means if you want 2yz to come minus 24, that means 2bc basically. If this is a, this is b, this is c. If you want 2bc to come out to be minus 24, either b should be with a minus sign or c should be with a minus sign. Right? Either b should be with a minus sign or c. Both cannot be. If both will be with the minus sign, then b into c will become positive. I want it to be negative 24. So either this will be positive, this negative, or this will be negative, this positive. Is it clear? So out of these two, which is positive, which is negative, we are going to get the hint from this expression. So here the last term will be 2 into c into a. If I continue keeping this positive, and if this is also positive, 2 into c into a will give me what? 16xz with a positive sign, but I want 16xz with a negative sign. This was already positive, not creating a problem, so this has to be negative. Out of these two, this has to be negative, and out of these two also this has to be negative to get these two terms with a minus sign and this with the plus sign. So actually I can write this as 2x whole square, 3y whole square, and this will be minus 4z whole square. See, of course, you can write this as 2x whole square as well as minus 2x whole square, 3y whole square as well as minus 3y whole square, 4z whole square as well as minus 4z whole square. But what actually we have to choose is this. So I am going to have a as 2x, this is my a, b as 3y, and c as minus 4z. such that a square plus b square plus c square plus 2 into a into b gives me 12xy, you can see that, plus 2 into b into c gives me minus 24yz, you can see that, plus 2 into c into a gives me minus 16xz. So I can write this expansion as this form, which is nothing but, you know, from here, from the right hand side, you have to move to the left hand side. So you have x square plus or a square plus b square plus c square plus 2ab plus 2bc plus 2ca, where your a, b and c are 2x, 3y and minus 4z respectively. So this is equal to 2x plus 3y minus 4z whole square. So you have expanded this expression and you have factorized this next expression. Let's move on to the next question. We have, find the value of k if x minus 1 is a factor of this polynomial. Try to recall the factor theorem. What did it say? It said that x minus a is a factor of fx if and only if a is a 0 of fx. So x minus 1 is a factor of px if and only if x equals 1 is a 0 of px. That is, by factor theorem, that is, x equals 1 is a 0 of px means in place of x when I will put 1, px will become 0. That is, p of 1 is 0. If p of x is this, what is p of 1? It will be k into 1 square minus root 2 into 1 plus 1 equals 0. That means k equals root 2 minus 1. Right? If k minus root 2 plus 1 is 0, that means k is root 2 minus 1. You have, by factor theorem, found out the value of k such that x minus 1 is a factor of px or x equals 1 is a 0 of px. Next I have, if x plus y plus z is 0, show that x cube plus y cube plus z cube is 3xyz. First of all, this we have to show. If you can recall, we know this, that x cube plus y cube plus z cube minus 3xyz can be written as x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. We are well versed with this expansion, right? Now why did I write this? Because it is connecting us to what we want to show. X cube is there, y cube is there, z cube is there, 3xyz is there. Fine. This is something that we know. Now it is given that if x plus y plus z is 0, if this is equal to 0, 0 into anything is 0. If this becomes 0, then clearly x cube plus y cube plus z cube minus 3xyz is equal to 0, which means that x cube plus y cube plus z cube is 3xyz. So you have proved that if x plus y plus z is 0, then x cube plus y cube plus z cube is 3xyz. Next it says that without actually calculating the cubes, find the value of this expression. Let's try to find the value of this expression. It is minus 12 cube plus 7 cube plus 5 cube. So let's write it down. Minus 12 cube plus 7 cube plus 5 cube. Try to focus upon the numbers carefully. If I take this as x, this is y, this as z, what is x plus y plus z? It is minus 12 plus 7 plus 5, which is minus 12 plus 12, which is 0. The moment x plus y plus z is 0, I am able to come back to this verification that if x plus y plus z is 0, then x cube plus y cube plus z cube is 3xyz. So here x plus y plus z is 0, so x cube plus y cube plus z cube, which right now is minus 12 cube plus 7 cube plus 5 cube, will be equal to 3xyz. That means 3 into minus 12 into 7 into 5. Directly, without even opening up the cubes, I have calculated the value of x cube plus y cube plus z cube as 3xyz, because x plus y plus z was equal to 0, and that is what we just proved. So here what do you have? What do you have? 12 into 5 is 60, 60 into 3 is 180, and 180 into 7 is, and therefore you get 1260 with a minus sign. Is it clear? Fine. So that's how you calculate this answer. Next we have factorize this polynomial of degree 3. Now the moment I have this, you should remember what we have done regarding the integral root theorem. Here the constant term is 2. So factors of 2, all the integral factors of 2 are plus minus 1 and plus minus 2. I will be checking out of these which actually is the 0, integral 0 of this polynomial. So let's just pick up, let's say this is fx. Out of these 4 values, which are factors of my constant term in the polynomial, plus 1, minus 1, plus 2 and minus 2, let me pick up 2. I get f of 2. F of 2 will be 2 cube minus 2 into 2 square minus 2 plus 2. Minus 2 plus 2 cancels out, this is 2 cube, this is 2 cube, cancels out, you get 0. So f of 2 is coming out to be 0, which means x equals 2 is a 0 of fx, and by factor theorem this means that x minus 2 is a factor of fx. So one factor we have found out as x minus 2, but it is a polynomial of degree 3. What are more factors? For that we will have to divide fx by x minus 2. If x minus 2 is a factor of fx, that means when fx is divided by x minus 2, the remainder is 0. What is the quotient that you get is what we need to find. So fx is x cube minus 2x square minus x plus 2. I will have to divide it by x minus 2, and I know the remainder will be 0 because x minus 2 is a factor. What I am curious about is what is the quotient. X into x square is x cube, minus 2 into x square is minus 2x square, this is minus, this is plus, and then you get this entirely comes down minus x plus 2, right? Now x into what is minus x? X into minus 1 is minus x, minus 2 into minus 1 is plus 2, again this is plus minus, you get a 0. So this is your divisor, this is quotient, this is dividend, this is remainder. You all know by division algorithm that dividend, your dividend is nothing but fx, x cube minus 2x square minus x plus 2, which is fx. Dividend is equals to divisor into quotient plus remainder plus 0, no relevance. So you can write this as x minus 2, this is a square minus b square, which is a plus b into a minus b. These are the 3 distinct factors of my cubic polynomial x cube minus 2x square minus x plus 2, and their product, the product of these 3 factors is what represents the factorization of my polynomial fx. That means the 3 distinct zeros of fx are x equals 2, x equals minus 1 and x equals 1. Is it clear? Next question says that evaluate the following products without multiplying directly. Okay, let's do that. Here if you see, you have 95 into 96. Now 95 can be written as 100 minus 5 and 96 can be written as 100 minus 4. Can you recall something from here? If you can recall this identity, x plus a into x plus b is x square plus a plus bx plus ab. So I can write this as 100 plus minus 5 into 100 plus minus 4. So now I have 100 as x, minus 5 is a, again 100 is x and minus 4 is b. So you have x plus a into x plus b, which is x square plus a plus b x plus ab. A plus bx, but x is 100. So you have 1, 1, 2, 3, 4 minus 900 plus 20. This gives you what? 9100 plus 20, which is 9120. So without actually multiplying, I have found the value of the product, which is 9120. Next is 104 into 106, 104 into 96. This can be written as 100 plus 4 and 100 minus 4. This again calls for the recall of one more identity, which was x plus a into x minus b, or x minus a. X plus a into x minus a is x square minus a square, or rather than that, if we remember it like x plus y into x minus y is x square minus y square is the same thing. So here basically what is it that you have? Let me write it in the traditional form. X plus y into x minus y is x square minus y square. So here this is x, x plus y, again x minus the same value y. It is x square 100 square minus 4 square, which is minus 16. This is 4, and you have 999 minus 1, which is 998. So 9984. Cool? Next question is, give possible expressions for the length and breadth of each of the following rectangles in which their areas are given. So there are two rectangles whose areas are given, and corresponding to these areas you have to give length and breadth. So first, area of rectangle is what? Area of rectangle is length into breadth of that rectangle. Area is given to me as 25a square minus 35a plus 12. If I am able to factorize it as something into something where both these are linear factors, then of course one would be corresponding to my length and one would be corresponding to my breadth. So all I need to do is I need to factorize this into product of two linear factors. You have 25a square minus 35a plus 12. Of course, if you try to break the middle term, 25 into 12 will be 300, right? And you know 15 into 20 is also 300. And minus 15 minus 20 is 35, minus 35. So you can write this as 25a square minus 15a minus 20a plus 12, because minus 15 minus 20 is minus 35, and minus 15 into minus 20 is plus 300, which is 25 into 12. This gives you 5a common, 5a minus 3, and you have here 4 common and 5a minus 3, minus 20a plus 12. So this gives you 5a minus 3, 5a minus 4. Obviously, I have been able to write area as product of two linear factors. This is going to be my length and this is going to be my breadth. So the length is, the possible length and breadths are 5a minus 3 and breadth would be 5a minus 4, or length can be 5a minus 4, breadth is 5a minus 3. Clear? Next I have 35y square. So let's write it down here itself. Let's do it for the next one here itself. So you have 35y square plus 13y minus 12. Again, I have to write it as product of two linear factors. What should be my two terms which I should multiply so that the product comes out to be same as 35 into 12 and the sum comes out to be 13? Let's try to see. 35 into 12 can be written as 7 into 5 is 35 and 4 into 3 is 12. Which can be written as 7 into 4 is 28 and 5 into 3 is 15. So 28 into 15 is same as 35 into 12, and 28 minus 15 is 13, right? Or I can say 28 plus minus 15 is 13. So I have got two numbers whose sum is 13 and whose product is same as 35 into 12. So what can I say here? 35y square plus 28y minus 15y minus 12. Now 28 minus 15 gives you 13 and 28 into minus 15 gives you 35 into minus 12. So this is 7y, 5y plus 4 minus 3y, or I should say 3, 5y plus 4. Right? This gives you 7y minus 3, 5y plus 4. So this is my possible length and this is my possible breadth. Clear? Talking about the next question, check whether this is a factor of this polynomial or not. In order to see this, we will have to divide the polynomial by this 7 plus 3x expression and see whether the remainder comes out to be 0 or not. Let's begin. 3x cube plus 7x, let's divide it by 7 plus 3x or 3x plus 7. 3x into x square gives me 3x cube. This is 7x square, so I'll write it separately. This is minus, what do you have? You have minus 7x square plus 7x. Now 3x into what will give me minus 7x square? Let's see. 3x into what will give me minus 7x square? So you can see x cancels out. 3 goes there, the question mark comes out to be minus 7 by 3x. So 3x should be multiplied with minus 7 by 3x to get minus 7x square, and 7 into this gives you minus 49 by 3x. 7 into minus 7 by 3 is minus 49 by 3 into x. This is plus, this is plus. 49 by 3 plus 7 gives you what? 49 plus 21 whole upon 3. This gives you 70 upon 3. 9 plus 1 is 10. 4 plus 2, 6 plus 1, 7. So 70 upon 3. This gives you 70 upon 3x. 3x into what will give me 70 upon 3x? See, I want in the remainder an expression which is free from x. I am searching for 0, right? So I am saying 3x into what will give me 70 upon 3 into x. So 3x into what will give me 70 upon 3 into x. X cancels out. You get question mark is 70 upon 9. So 3x into 70 upon 9 will give me 70 upon 3 into x, and this will be 7 into 70 upon 9, which is 490 upon 9. Then you will have minus, minus, this gets cancelled out. You have minus 490 upon 9 as a constant coming out as the remainder, which is not equal to 0. When you are dividing this cubic polynomial by this linear polynomial, the remainder is not coming out to be 0, and therefore 3x plus 7 is not a factor of 3x cubed plus 7x. Is it clear? This is your rough work, of course. And that brings me to the end of the discussion. Please revise all the questions very nicely. It's covering all the concepts that are there in the chapter. That's it from my side. Thank you.